Hi everybody! Today we're going to talk about inequalities. Here are your new vocab terms for inequalities. An inequality is a mathematical sentence containing any of these symbols. So less than, greater than, less than or equal to, or greater than or equal to. Maximum, the greatest amount possible, and minimum, the lowest amount possible. Here are the four symbols that we use for inequalities: less than, greater than, less than or equal to, or greater than or equal to. If you notice, there are some different ways of saying these different four symbols. Like, for example, if we're talking about something that is less than, we could also say fewer than. For greater than, you might hear it as more than or exceeds. So, for example, if the number of girls in the room exceeds 10, that would mean that there are more than 10 girls in the room. Now, does that mean there could be exactly 10 if it exceeds? No, exceeds means it has to go beyond, so not exactly 10, but more than 10. Next, we have the less than or equal to. We might hear that as is no more than, or is at most, or the maximum. So the maximum number of people we can fit in this room is 40. That means we can't go above 40, but can we have exactly 40? Yes, that is the maximum. So that's why we use the less than or equal to. So you can have equal to 40 or less than 40. And then on the flip side of that, we have the greater than or equal to. You might also hear that as is at least or the minimum. So when you go to an amusement park, sometimes there's a height requirement in order to ride a ride. So if you need to be at least 48 inches tall to ride the ride, that would mean you'd have to be exactly 48 inches or more than 48 inches. That would be why we use the greater than or equal to symbol. All right, so now using what we just talked about in that chart, let's go ahead and write an inequality for each of these situations. The first one says, your age is greater than 6 years. So what we're going to do is we're going to use that chart. When we pick a variable to write an inequality, let's pick a variable that has to do with the situation. So if we're talking about age, then the variable we would want to use is, that's right, an A. So the age is greater than 6. So A is greater than 6. Number 2, your speed is less than 35 miles per hour. So speed is less than 35 miles per hour. Next, we have your height is at least 40 inches. So now if we think about this one, if your height is at least 40, that means that you could be exactly 40. So we're going to have the equal sign on there. Or if it's at least, that means you could also be greater than 40. Next, your speed is no more than 25 miles per hour. So that means you can't be going more than 25 miles per hour. So that would mean your speed would have to be less than 25, or it could be equal to 25 because it just says no more than 25. So 25 is the maximum. Next, the minimum age requirement is 13 years. So if the minimum is 13, that means that you can be exactly 13 years old or more because that's the minimum. And then lastly, you can have no more than 5 pieces of candy today. So how much can you have? How much candy? No more than 5 pieces. So can you have exactly 5 pieces? Yes, but not more than that, so that would mean less than. All right, the next thing we're going to talk about with inequalities is, for the given value, state whether each inequality is true or false and show your work. So what I found in the past is that kids do much better and are more successful at these when they show their work. And here's how I would like you to do that. So we have an inequality here, x minus 7 is less than 5. We want to know, is it true or false if x is equal to 14? So let's go ahead and substitute in 14 where the x is. And what we're going to end up with is an inequality that we want to test and see if it's true or false. So is 7 less than 5? No, that would be false. Get the idea? Let's go ahead and try the next one. 12 is greater than or equal to a divided by 2 plus 2. Let's substitute in 20. So the 12 is greater than or equal to stays the same. We're going to plug in 20 for a. And now we're going to simplify this side of the equation. Okay, so we end up with 20 divided by 2, that's 10, and then plus 2 is 12. So we end up with 12 is greater than or equal to 12. So this one ends up being true. Now, if the answer had been 12 is greater than 12, that would not be true because it does not have the or equal to sign underneath it. All right, now it's your turn. Go ahead and pause the video, try the next 2 problems, and then play the video to check your answers. Okay, let's see how you did. So 3 plus 6 is less than or equal to 12. That would mean 9 is less than or equal to 12. That would be true because 9 is less than 12. And for the other one, we have 17 minus 7 is less than 10. So 10 is less than 10. That's false because it doesn't have the or equal to sign underneath. Nice job. Okay, so now we're going to move along and we're going to talk about graphing the solutions of an inequality on a number line. So there are 2 different types of points or dots that we're going to use when we're graphing on a number line. We're going to use an open dot for the symbols that are less than or greater than. And then we're going to use a closed dot for the symbols that are less than or equal to or greater than or equal to. Make sure you write that part down. Okay, so for the first question, it says x is greater than -5, and we want to graph all of the solutions to this inequality on a number line. So what are some possible solutions for x? What are some numbers greater than -5? -3, -2, -1, 0, 1, 2, 3, 4, 5. We could continue counting because there's an infinite number of numbers that are greater than -5. So somehow we need to show that on our number line. So first thing we need to do is make sure that on our number line we have evenly spaced tick marks. And we always want to label 0 on our number line. So I'm going to label this tick mark right here, 0. Now, -5 is the number in question. So the first thing I want to ask you is -5 a solution to our inequality? Is -5 an actual answer for x? So we test it. Is -5 greater than -5? No, it's not. And so what that means is on our number line, we're going to go to -5, label it, and we're going to put an open dot at -5 to show that -5 is not actually a solution to this inequality. Now, we talked about the numbers that are solutions, though. We said that -4, -3, -2, -1, 1, 2, 3, 4, 5, all of those are solutions. So are those numbers to the left of -5 on the number line, or are they to the right? They are to the right. And so what we do is we show that those are all solutions by drawing a nice big arrow starting at the 5 and going to the right, saying anything that's covered in this green arrow is a solution except not -5, and that's why there's an open dot there. Okay, let's go ahead and try the next one. Let's get some tick marks on our number line here, and let's label 0. So x is less than or equal to 7. So first thing I want to know is 7 a solution to our inequality? Is 7 less than or equal to 7? Since 7 is equal to 7, that means it is a solution. And so when I go to the number 7, here it is, I'm going to put a closed dot to show that 7 is a solution. Now, what numbers are solutions? Anything less than or equal to 7. So where are the numbers less than 7? They are to the left this time. So we draw a nice big arrow to show anything to the left of 7. All right, now I want you to go ahead and try the next one. So draw your tick marks on your number line, pause the video, go ahead and try graphing x is greater than 1, and then play the video to check your answer. Okay, let's go ahead and see how you did. So here we have 0 and 1. Am I going to have an open or closed dot at 1? Well, x has to be just greater than but not equal to 1. So that means I'm going to use an open dot at 1. If x's are greater than 1, that means I want to shade everything to the right. Hopefully you got that one. If not, let's try another one. So the next one is written a little bit differently. If you notice, the number and the variable are switched. So let's take care of that right away, and let's actually change this around so it looks like the other ones. So instead of 2 is greater than x, let's do x is less than 2. If you flip the order of the number and the variable around, you also have to change the symbol in the middle. Okay, so pause the video. I want you to go ahead and try the next two problems, graphing the inequalities, and then play the video to check your answer. Okay, let's go ahead and see how you did. So you should have an open circle at 2. And then if x is less than 2, that means our arrow needs to be going to the left. And for the last problem, it is written backwards, so let's flip this around. We have x and -3. Flip our symbol in the middle. So at -3, I'm going to have a closed dot because -3 is a solution. And then if x is greater than or equal to -3, all the numbers greater than -3 are to the right. Fantastic job, everybody. Let's move on. Okay, so now the last part of this lesson is kind of doing the opposite. We're going to write the inequality for the graph instead. So if you notice for this first one, we do have a graph. I would say the easiest way to start these would be to first start with your variable and your number, because you know there has to be a variable. The number that has the dot on it is 3. So I'm going to have an x and a 3. The only thing we need to figure out now is what symbol goes in the middle. For this graph, this is a closed dot, so we know my options for a closed dot are either less than or equal to or greater than or equal to. We just got to figure out which one goes in our inequality. So we look at our arrow. What numbers are shaded in our arrow? Less than 3 or more than 3? Less than 3. So that means we have to use the symbol that has the less than symbol in it. So x is less than or equal to 3. All right, go ahead and pause the video. Try the next couple. Let's see if you can get it, and then play the video to check your answer. Okay, let's see how you did. So we need a variable and we need a number. In this case, it's going to be -3. Now we're going to look to see if it's an open or closed dot. Since it's open, my options are either less than or greater than. What numbers are shaded? All of the numbers greater than -3 or bigger, so I need to use the greater than symbol. And the last one, let's go ahead and put our x and +1. Taking a look at our dot, it's colored in, so we know it has to be one of these two symbols. All of the numbers larger than 1 are shaded, so I need to use the greater than or equal to symbol. Nice job hanging in there for this one. Have a great day, everybody.